Good evening. People are still coming in, so we'll take a couple more days, couple more minutes before we start. Okay, thank you. Okay, good evening once again. It's right after 8:05, so we better start because time is limited, as you will see. We have a lot to cover. Today's training program, or the training program that we are starting today, is part of component S8A of the Urban Resilience Project Rajuk part, which is directed by engineer Abdul Latif Hilali of Rajuk. The component that we are implementing is component S8A, and it is titled Professional Accreditation Program Strengthening. Bangladesh has an existing professional engineering registration program, PEng. In addition, we propose to introduce a structural engineer registration program, S.Eng. The document that you see on the screen was sent to all applicants for our training program 3 days or so ago. I believe it's an important document for you to read because here we try to explain as clearly as possible the differences between the existing there are some songs coming through. anyway, the differences between the existing PEng and the S.Eng program that is being introduced. Now, we as consultants, ICC as consultants, is supposed to carry out a piloting project under which a certain number of civil engineers will take an exam and will be registered as structural engineers. And all of these candidates for the exam will need to undergo training according to the terms of reference for our project. So this is the beginning of that training, just so that you have a perspective on it. I think if you read the document, you will have a clearer idea of what all of this is about. And with that, we are about to launch into the training itself. But before that, it would be most appropriate to have Engineer Nurul Huda, President of IEB, who has been a great supporter of this program from the beginning and has extended full cooperation of IEB. It would be most appropriate for him to say a few words at the beginning of today's program. So I would like to invite, I would like to ask Bodhi to unmute him so that Engineer Nurul Huda can start speaking, and I will come back on after he is done. Thank you, and it's a privilege to introduce to you Professor Nurul Huda, President IEB.
Thank you very much, Dr. S.K. Ghosh, President S.K. Ghosh Associate and Limited, and at the same time ICC consultant. Bismillahir Rahmanir Rahim. আমি প্রথমেই আন্তরিক ধন্যবাদ জানাচ্ছি ডক্টর এস.কে. ঘোষকে এবং তার সঙ্গে সঙ্গে রাজুক আরবান রেজিলিয়েন্স প্রজেক্ট এর সঙ্গে যুক্ত যারা আছেন তাদের সবাইকে, এবং এট দ্য সেম টাইম আমাদের কনসালটেন্টের প্রার্থী যারা আছেন তাদের সবাইকে আমার পক্ষ থেকে আন্তরিক ধন্যবাদ ও মোবারকবাদ জানাচ্ছি। তার সঙ্গে সঙ্গে আমরা ইঞ্জিনিয়ার্স ইনস্টিটিউশন বাংলাদেশের পক্ষ থেকে, নির্বাহী কমিটির পক্ষ থেকে আমরা এই প্রজেক্টটা বাস্তবায়নের জন্য আমরা একটা কমিটি করে দিয়েছি। সেই কমিটির কনভেনার হলো আমাদের ভাইস প্রেসিডেন্ট প্রকৌশলী মোহাম্মদ নুরুজ্জামান, এবং আমাদের এটা মেম্বার সেক্রেটারি হলো আমাদের প্রকৌশলী শেখ তাজুল ইসলাম তুহিন। এদের দিয়ে আমরা যে কমিটিটা করে দিয়েছি, সেই কমিটি আমাদের কনসালটেন্ট সহ রাজুক সহ সুন্দরভাবে আজকের এই প্রোগ্রামটা বাস্তবায়ন করার ক্ষেত্রে আজ দূর আমরা এগিয়ে গিয়েছি। আমি ওইটার সঙ্গে যুক্ত সবাইকে ইনস্টিটিউশনের নির্বাহী কমিটির পক্ষ থেকে, কাউন্সিলের পক্ষ থেকে আন্তরিক ধন্যবাদ ও মোবারকবাদ জানাচ্ছি। তার সঙ্গে সঙ্গে আমাদের স্ট্রাকচারাল ইঞ্জিনিয়ার, যেটা আমাদের ইঞ্জিনিয়ার্স ইনস্টিটিউশন বাংলাদেশের পক্ষ থেকে যারা প্রফেশনাল ইঞ্জিনিয়ারিং ডিগ্রি নিয়েছেন, তাদের মধ্যে থেকে যারা স্পেশালি স্ট্রাকচারাল ইঞ্জিনিয়ারিংয়ের সঙ্গে যুক্ত এবং আমাদের ডিজাইনের সঙ্গে যুক্ত, তাদের থেকে আমরা এই যারা এটার সঙ্গে যুক্ত ছিলেন তাদের থেকে আমরা বাছাই করে সর্বমোট 550 মতো আমরা এই প্রোগ্রামের অন্তর্ভুক্ত করেছি। আমি আশা করি ইঞ্জিনিয়ার্স ইনস্টিটিউশন বাংলাদেশের সম্মানিত সদস্য এবং আমাদের প্রফেশনাল ইঞ্জিনিয়ার্স যারা নিয়েছেন, যারা স্ট্রাকচারাল ইঞ্জিনিয়ার সঙ্গে যুক্ত, তারা আগামী দিনগুলোতে আমাদের রাজুক কর্তৃক যে ডিজাইন করা হবে এবং তার সুপারভিশন করা হবে এবং সেটা বাস্তবায়ন করা হবে, এটার সঙ্গে এই স্ট্রাকচারাল ইঞ্জিনিয়ার আজকে যারা ট্রেনিং নিচ্ছেন তারা যুক্ত থাকবেন। আমরা প্রথমবারের মতো ইনস্টিটিউশনের পক্ষ থেকে আমাদের রাজুকের সহযোগিতা এবং আমাদের ডক্টর এস.কে. ঘোষের সহযোগিতা আমরা এই কর্মসূচিটা গ্রহণ করেছি। আমি মনে করি আমাদের জাতীয় ক্ষেত্রে এবং আন্তর্জাতিক ক্ষেত্রেও এটা একটা বিরাট প্রভাব ফেলবে। আমরা ইতিমধ্যে আমরা ইঞ্জিনিয়ার্স মোবালিটি ফোরামের আমরা পার্মানেন্ট মেম্বারের জন্য, এবং আমরা তার সঙ্গে সঙ্গে আমাদের ইঞ্জিনিয়ার্স আইপি এর পার্মানেন্ট সদস্যের জন্য আমরা টেম্পোরারি আমরা মেম্বারশিপ পেয়েছি। পার্মানেন্ট মেম্বারের জন্য আমরা ইতিমধ্যে আমাদের চেষ্টা অব্যাহত আছে। আমরা আশা করি ইনশাল্লাহ আগামী অল্প দিনের মধ্যেই আমরা এই দুইটা সেক্টরেই পার্মানেন্ট মেম্বারশিপ অর্জন করতে সক্ষম হব। আমি এই প্রজেক্টে আমাদের ইঞ্জিনিয়ারিং স্টাফ কলেজের মাধ্যমে এই ট্রেনিংটা সম্পন্ন হবে। আমি ইঞ্জিনিয়ারিং স্টাফ কলেজের রেক্টর মহোদয় এবং তার সঙ্গে যারা যুক্ত আছেন তাদের সবাইকেও আমার পক্ষ থেকে আন্তরিক ধন্যবাদ এবং মোবারকবাদ জানাচ্ছি। আমি আশা করি এই ধরনের আমাদের প্রফেশনাল কর্মকাণ্ড আগামী দিনগুলোতেও অব্যাহত থাকবে, এবং সেই ক্ষেত্রে আইসিসির কনসালটেন্ট আমাদের ডক্টর S.K. ঘোষের যে উদ্যোগ, এটা বাস্তবায়ন হবে। আগামী দিনগুলোতেও আমরা একসাথে কাজ করব, এই আশাবাদ ব্যক্ত করতেছি। আমি রাজুকের চেয়ারম্যান সহ রাজুকে যারা যুক্ত আছেন তাদেরকে, আমাদের S.K. ঘোষ সহ ডক্টর S.K. ঘোষ সহ তার সঙ্গে যারা কনসালটেন্টে যুক্ত আছেন তাদেরকেও আমি আন্তরিক ধন্যবাদ জানাচ্ছি। আমাদের ইঞ্জিনিয়ারিং স্টাফ কলেজের রেক্টর সহ তার সহকর্মী যারা, তাদেরকেও আন্তরিক ধন্যবাদ জানাচ্ছি, এবং আমাদের যারা অংশগ্রহণ করতেছে তাদেরকেও আন্তরিক ধন্যবাদ জানাচ্ছি, এবং আমাদের ভাইস প্রেসিডেন্ট নুরুজ্জামান এবং তুহিনের নেতৃত্বে যে কমিটি কাজ করেছে তাদেরকেও আন্তরিক ধন্যবাদ জানিয়ে আমি সবাইকে আমার পক্ষ থেকে আবারও ধন্যবাদ জানিয়ে এই ট্রেনিং প্রোগ্রামের সাফল্য কামনা করে আমার বক্তব্য এখানে শেষ করছি। উপস্থিত সকলকে আবারও ধন্যবাদ। থ্যাংক ইউ অল।
আপনাকে অনেক ধন্যবাদ প্রেসিডেন্ট নুরুল হুদা। আমি আপনারা অনেকেই জানেন আমি শিকাগো থেকে কথা বলছি। এখানে এখনো সকাল। আজকে সকাল থেকে যেভাবেই হোক রবীন্দ্রনাথের কটার লাইন মনে পড়ছিল, সেই দিয়ে আরম্ভ করি, আপনারা যদি কিছু মনে না করেন, কারণ এটা মনে হয় আমার। যাই হোক, লাইনগুলো হচ্ছে: মনে হলো যেন পেরিয়ে এলেম অন্তবিহীন পথ, আসিতে তোমার দ্বারে মনে হলো, মরুতীর হতে সুধা শ্যামলিম পারে মনে হলো। এইবারে আমাদের এই প্রোগ্রাম নিয়ে এত রকমের বাধা প্রতিবন্ধক গেছে যে আপনাদের বলে বোঝানো যাবে না। সেই কারণেই এই লাইনগুলো আমার কাছে খুব রেলেভেন্ট মনে হয়। সুধা শ্যামলিম পারে এখনো একেবারেই পৌঁছানো যায়নি, তবে আমি ভরসা রাখি যে আমরা মরুতির পার হয়ে এসেছি। অন্তত প্রোগ্রামটা আজকে আরম্ভ হচ্ছে, আশা করি মোটামুটি ঠিকভাবে গিয়ে মার্চ মাসের মাঝামাঝি আমরা এটাকে শেষ করতে পারবো আপনাদের আশীর্বাদে। ওকে, এবারে আরম্ভ করা যাক টেকনিক্যাল প্রেজেন্টেশন। So we have a two-part presentation today. The first part is just a general introduction to building codes. We thought that that would be an appropriate beginning to the whole program. The
Rather,
first question.
you're not on the slideshow mode or presenter mode.
Oh yeah, okay.
Yeah.
The first question is, we are spending a whole lot of resources and effort in trying to get BNBC 2020 implemented first and then enforced. But why? What is the importance of building codes? Why building codes? So this is very basic. All communities need building codes to protect their citizens from everyday disasters like fires, weather-related events such as floods, and structural collapse that follows deterioration over time of buildings of all kinds. Okay, so protect citizens from everyday disasters, protect citizens from disasters that happen once in a while like floods, and age-related deterioration ultimately will destroy any structure, and to the extent that we can take steps to preserve structures to prolong their life, that also belongs in building codes. Building codes serve as a means of prevention. This is truly, in a very basic sense, building codes prescribe preventive measures to keep bad things from happening. It provides us with a choice between an ounce of prevention today and a pound of suffering in the future. If we build code complying structures, chances are very high that for many decades, the structure will serve our purposes satisfactorily with minimal maintenance. But if we don't do things right in the first place, we do not comply with the code, we cut corners, then the consequences can be quite unhappy and may result in a whole lot of suffering. This picture I have shown a half a dozen times, I think, on various occasions, because I personally believe that I do not have anything better to emphasize the importance of building codes and what they do for you. What is presented on this slide are statistics that were collected by the Disaster Prevention Research Institute at the University of Kyoto following the Kobe earthquake of 1995. What you see on the x-axis is essentially the age of the structure. The first bunch of structures were constructed before 65, then those constructed between 66 and 70, and so forth. The statistics were compiled in 95, so obviously the x-axis doesn't go beyond that. On the y-axis is number of, not number, the percentage of total structures within each age group that suffered severe damage or collapse, that's shown in yellow, moderate damage shown in dark blue, minor damage shown in red, and no damage shown in green. Okay, so the oldest structures dating back to 65 or before, 60% suffered severe damage or collapse. 20% suffered moderate damage, something like 12% suffered minor damage, and something like, 5-6% suffered no damage. You go to the newest structures, okay? None suffered, none. No, not a single structure suffered severe damage or collapse, or moderate or even minor damage. Okay, the entire population of new structures, slight or no damage. So as the age of the structure decreases, the proportion of severe damage decreases, the proportion of no damage increases. And the reason is the Japanese building code underwent two very, very important changes in 1971 and 1981. No, I'm sorry, 1981 and 1991. Okay. Now, 1981 change was analogous to what happened after the 73 earthquake in the United States, after the San Fernando earthquake. And that was the beginning of ductile concrete construction in this country. After a very major devastating earthquake, the Japanese code was changed in 1991 to reflect some of the same philosophy and so forth. So post-1981 structures has performed a lot better than pre-1981 structures. And then in 1991, following another devastating earthquake, they made a major code change where they introduced a two-part design procedure. You design for no collapse under a severe earthquake, but you also design essentially for serviceability under very frequent earthquakes. And since then, code complying structures have done really wonderfully in Japan. So this shows you that building codes properly formulated, properly enforced can directly save life. The last well, Japan always has earthquake, but the last major event was, as you remember, in 2011. This is magnitude 9.0. That's not even like imaginable how this is about the largest that can happen. And a lot of people died in tsunami. A nuclear power plant was in trouble. All of you know all of this. We went to look at earthquake and tsunami damage not immediately after an earthquake, when search and rescue and things like that are taking place, is not the time to go. We went, I don't remember now, 3 weeks to a month after the event. This is Sendai Airport. Sendai was the city closest to the epicenter. You see that the airport building is not only standing, it is functioning. This is where we flew in. We saw damage. It was not damage free, but considering the magnitude of the earthquake, the damage was very light indeed. When we came out of the airport waiting to be picked up, this is what the city looked like. You look at the traffic. There was essentially no sign of an earthquake having taken place within just 3 or 4 weeks before. If you looked hard, yeah, there were signs, but there was basically not a whole lot to see. So I'm not saying that there was no damage, but if you drove around the city, you might not see a whole lot until somebody pointed things out to you, and then you did see earthquake damage. Now, we were taken to the campus of Tohoku University just outside of Sendai, and many of the university buildings were old. This is one of them. These are shear walls that are coupled, as you will see in the next picture. These coupling beams between the shear walls had openings for some reason. I do not know why. And those suffered pretty much as expected, very major, very substantive damage. And then the columns of the building, this is an older building, the columns had the pre-1981 detailing. This we would call it non-ductile detailing. The main feature of which is that you have plenty of longitudinal reinforcement, but hardly any transverse reinforcement. There are typically ties at 14-inch or so spacing. The ties are once around. There are no cross ties or anything, and the hooks at the ends are 90 degrees. Everything is wrong, and those columns always suffer shear or shear compression failure, as you see in these pictures. So in this older building, there was plenty of damage to be seen, but as I mentioned, buildings designed and built by the later codes did incredibly better. The tsunami was a totally different story. All the the coastal communities, there were fishing villages or fishing towns, and this is one of them. I don't remember the name now, Onagawa, something like that. Uh, you went to any of these places, and we went to many. It really is very depressing even to watch. All you saw were an occasional concrete building still standing up. When I say building, is the skeleton of the building. Everything else is gone. Uh, People's possessions are all over the place. Children's shoes, family photographs, clothes. It just and typically they were collected in heaps, uh, and other than some workers, there was no one around. It was total, complete devastation. In stark contrast with what happened as a direct result of the earthquake. So tsunami is a different story. We will not go into that today, but my point in showing you everything so far was that Japanese building codes are technically sound. Much more importantly, they are very strictly enforced, and as a result of that, at least all, I would say, post 1981 structures, particularly post 1991 structures, have performed very, very satisfactorily in recent Japanese earthquakes. Earthquake threat is not taken seriously in Bangladesh, at least by the public, although the World Bank seems to be very aware that it exists and that it may cause very, very serious problems. And it is true. I think many of you in Dhaka felt an earthquake about a month ago, this particular earthquake of magnitude 6.2 that originated outside of Bangladesh in Burma. This was the epicenter of the earthquake. This is Dhaka. So, and 6.2 is not small. It's not a large earthquake, but it's not a small earthquake. And the epicenters of these are earthquakes in the last month or so. So there is earthquake activity going on. Luckily, the largest one in the last month has been 6.2. And the epicenter is far enough away from, at least from Dhaka, not from the border of Bangladesh, but a larger earthquake closer in, you can easily appreciate might cause much more severe consequences. Earthquakes are natural disasters. The disaster that really has haunted the public in Dhaka and in Bangladesh is the man-made hazard of fires. I will mention only two: the Chowk Bazaar fire of 20th of February of 2019 was the year. This is what happened. A fire, and much of these things should not happen. That's the point. A fire started as a result of a road accident of all things between a pickup van and a private car. After the collision, a gas cylinder stored in the private car exploded. The first place the flames hit was a chemical warehouse on the ground floor of a 5-story building, and the flames that quickly spread through 4 other buildings, including a community center where a wedding party was on. The fire left at least 80 people dead and 50 others injured. So imagine this is a chemical warehouse on the ground floor of a building where people live in a congested neighborhood. Yeah. This definitely is not permitted by any code. This should have been detected by enforcement personnel and totally gotten rid of. Obviously, that was not the case, and people died. Dying is kind of final. The what also happens is people get injured and people become homeless. There are endless dire consequences to deal with by the families and by the authorities, and it's just a tragedy all around. The more recent, the effort tower fire in Banani. This was March of 19. The FR tower, which was built before 2006, did not have a single fire protected staircase, and the main staircase was filled with choking smoke. At just 0.6 meter, the spiral staircase outside, and 1.2 meter wide, which was the main staircase inside, the building's two exits were too narrow for people inside to leave easily. They were also blocked by obstructions that made the task even harder. Office workers able to reach the top of the building were rescued by Air Force helicopters. This is now the telling thing. According to news reports, the Bangladesh Fire Department had sent 2 letters in the prior 2 years highlighting the dangerous lack of safety in the building. Authorities knew the multi-story block was unsafe. The tower building, in fact, was supposed to be just 18 stories high, but was illegally extended to 23 floors. All of you know all these stories, and even the details, but the point is that code violations lead to major tragedies that are totally avoidable. Okay, why building codes? Building codes are minimum requirements. That is extremely important. Building codes always give us minimum requirements established by society that ensure an acceptable level of safety of building occupants and protection of property. That is not the primary aim of a building code, but protection of property is considered in formulating building codes. Okay, minimum requirements established by society that ensure an acceptable level of safety of building occupants and protection of property. When building codes work sufficiently, nobody notices. It seems like it doesn't have to be said, but or that is a trivial statement, but it is actually important. When building codes work, it's like when your body works, you take it for granted. It is only when it doesn't work that you get concerned, you pay attention, you do this, you do that. And it is the same thing. When building codes work, nobody notices. When they fail, society demands stronger, more robust building codes. And then we react and sometimes overreact and do things that need to be scaled back. Evolution of building codes. That the first known building code was the Code of Hammurabi. This is 2000 BC, roughly. And Hammurabi not only had a building code, he had a comprehensive code on how essentially how life should be conducted in all its facets. And some of it is very interesting reading, just like the building code. In the case of collapse of a defective building, the builder is to be put to death if the owner is killed by accident. So this is eye for an eye, tooth for a tooth kind of a thing. So the builder is to be put to death if the owner is killed by accident, and the builder's son will be put to death if the son of the owner loses his life. The interesting part to me is no mention of the daughter or wife or anything. It's the builder, the owner, the builder's son, and the owner's son. I guess 2000 BC, that's how society was. But anyway, very simple concept. It is about building falling down, structural stability or failure, and the punishment is rather severe, as you can see. Now, this is, I think, a very important slide. So we started with the Code of Hammurabi from the Babylonian times. Structural safety was the only thing that used to be considered. I don't know how much later fire safety became a very significant issue to be dealt with in building codes. So it was not just structural safety, it was fire safety. Then it became the health, safety, and welfare of the occupants of the building. If you breathe the inside air, are you going to get sick? That kind of consideration. Okay. Or even like you have steps that cannot be easily seen, then people are likely to fall. That's a health hazard that you have created inside the building. So that kind of consideration came into codes. Later on, durability became a consideration that was also incorporated into codes. What is the expected design life of a structure? Is it 50 years? Is it 75 years? Is it 100 years? If it is 100 years, what are we supposed to do in the structure itself? Is it going to be all stainless steel reinforcement, or is that unnecessary? That sort of thing. Maintenance or ease of maintenance became a code consideration. Property protection. I don't know that the sequence is all that important. It should not be implied that property protection was considered after building maintenance was considered, but property protection became a significant issue somewhere along the way in our building codes. Lately, as you know, it has been sustainability. We do not want our natural resources to be depleted, and we need to do everything we can to preserve those resources while constructing buildings. And the final thing today is resiliency, not just seismic, but resiliency, meaning a whole community being able to bounce back quickly after a natural disaster. That is now seriously becoming a code consideration. And I expect that in the next 6 to 10 years, there will be major strides made in at least in the United States. So today, the role of building codes is more holistic, and they have a greater impact on communities beyond that of safety of the building occupants. There is focus on higher performance, need to preserve scarce resources, energy, and water efficiency. Also, allow for an innovation in building design, materials, systems, and methods. That has been coming in gradually, and all of these things can be discussed at some length, but obviously this is not the occasion. Uh, so continuing on the same vein, today the role of the building code is more holistic. Uh, affordability in housing to support availability, to support affordability, the so-called low-cost housing. Even that has come into some codes. How to make livable structures at lower cost. Can the code do something to facilitate that? Then community needs for greater resiliency, which I mentioned already. Now, benefits of building codes. A building code provides safety and security for our loved ones. That's extremely important. In our S9 project, code enforcement, building code enforcement, we have come up with audiovisual material. Our consultant, Malay Chaki, a very talented man, has come up with a short movie where this safety of occupants is emphasized in a very nice way. I hope that you will have an opportunity to watch this short movie. So safety and security for our loved ones. A building code protects one of our greatest financial assets. One's home is a major financial asset for most people, and the building code protects it, provides more resilient communities, helps preserve a country's building stock. I think these are obvious benefits. Very importantly, a building code is not and cannot be a static document. A building code needs to be periodically updated in view of society's changing needs and values. That is important. Society's needs and values change, as we are all aware. New technology is always developing all around us. We need to take advantage. We need to acknowledge those things and adjust. New research is showing us better ways of doing things, more cost-effective ways of doing things. Those need to be incorporated into codes. Then when there is distress in buildings and they can be traced to a deficiency in our building code, obviously that has to be corrected. And this we do on an ongoing basis with all US codes. And finally, need to clarify provisions. This is an unending need. ACI 318 for concrete design and construction. I cannot tell you how many times I have read many of the provisions there. Even now, when I read something, I may be confused. The clarity is very difficult to achieve in written language, particularly if the language is meant to be enforced. So anyway, I'll leave it there, but this last item is not trivial at all. A code provision, because it is meant to be enforced, because it has legal mandate behind it, has to be as clearly written as possible, has to be unambiguous to the extent possible, and that requires constant effort. Then the next things are also extremely important. A building code applies to new buildings. This is always the case in every country of the world, and not to existing buildings. A new code edition becomes effective on a certain date. From that date on, all applications for construction permits must be for buildings complying with the new code edition. When a new code edition goes into effect, existing buildings need not be evaluated or modified in any way. This is very, very important. New buildings get applied to an existing building or part of an existing building only if the existing building is modified in some way. It is added to, it is altered, and so forth. If addition or alteration is made to an existing building, depending upon the extent of the addition or alteration, the addition, the altered portion, or the entire building may have to comply with the code in effect at the time a permit for such addition or alteration is applied for. Everything said here is extremely important. So a new code does not apply to an existing building. Having said that, if an addition or an alteration is made to an existing building, depending upon the extent of the addition or the extent of the alteration, the addition itself, the altered portion, or if the addition or the alteration is major, then the entire building, entire altered building may have to comply with the code in effect at the time the permit for such additional alteration is applied for. Okay. So these are commonly called triggered. How, when is an addition so large that the entire building, including the addition, has to comply with the new code? These are typically referred to as triggers, and that goes into significant other territory that is not our subject today. So minimum requirements we talked about earlier. This is a repeat. A building code provides minimum requirements. A designer may and indeed should go above or beyond the code, that is, follow more stringent requirements, if in his or her judgment the added stringency is needed for safety and or performance. This is extremely important. If in the engineer's judgment he should go beyond the minimum code, this is exactly what he's supposed to do. He is the engineer. The code is the minimum. What should be done to the structure should be decided upon by the professional, not that the code minimum is not always the right answer. Then I titled this "More is not necessarily better." I think all of you need to keep this in mind for all time to come. And an over-reinforced concrete member performs much worse than an under-reinforced member in an overload situation. I have seen so many places, because the reinforcing steel is more expensive than the concrete. The layman's way of looking is, if you put more reinforcement into a column, you have a better column. Yeah. You have got more for your money, and then that can be that is absolutely not the case. So over reinforced concrete member performs much worse than an under reinforced member. The over reinforced member tends to fail explosively and without warning. That is the difference. Okay. If an over reinforced member is overloaded, it will fail all of a sudden and explosively. If your column has a lower amount of reinforcement, it will probably fail, but fail gradually. It will give you warning. It will crack first. It will deflect first. You will know that something is going wrong. The above is particularly important in seismic design. Structural steel and reinforcing steel strength must not be more than specified. you specify grade 60 steel, you cannot just replace that with grade 75 because it is higher strength, so better. That that will cause significant problems. A structural member must not contain more reinforcement than required by design. Okay. So again, all of these I could elaborate on, and there will be occasions when I will do that in this training program. But please do keep in mind more is not necessarily better, and that is particularly true in earthquake situations. Okay, our S9 project was code implementation and enforcement. And I saw that the two terms were being used interchangeably. And they're not interchangeable terms. They are different things. What is implementation? The act of putting something into effect. That is implementation. What is enforcement? Enforcement is making sure that rules are followed, that violations are rectified, that violators are penalized or punished. Implementation and enforcement are not interchangeable terms. Now, BNBC 2020, which is our code today, the gazetting of that document after a long wait happened on 18th of February of it should be 2021. Last year. I don't know. That's a major mistake. I'm sure I wrote it myself. So to implement this document, Rajuk will need to update their Vidhimala to BNBC 2020, which is underway, I'm happy to say. I think I know that progress has been made, although the effort has not been completed. Launch an awareness campaign. We have various things going on. We have not emphasized the new edition versus the old edition kind of thing, which for professionals is important. This is something we probably should still think about. From the beginning, we have felt that a commentary to BNBC 2020 is an absolute necessity. Professionals have told us so, and hopefully as part of phase 2 of this URP Rajuk part, we will get to do that. Develop support literature, how to design using the building code. That is the role of support literature. It is not commentary. It tells you how to use the code in designing and constructing structures. That is needed. And then training of professionals at all levels. So all those are parts of implementation. So this is what the gazetted BNBC 2020 looks like. You may see this picture once or twice more. So we just talked about implementation. Enforcement has essentially two parts. When an owner or a developer wants to put up a building of some kind, a structure of some kind, he has to apply for a construction permit to the authority having jurisdiction. And he will have to submit to the jurisdiction drawings and calculations for the structure that he wants to construct. These drawings and calculations must be in accordance with, must be in compliance with the building code in effect. The jurisdiction needs to check that and make sure that there is compliance. If the jurisdiction finds that the drawings and calculations comply with the code, they will issue a permit, and then construction can proceed. If, however, they find that there are problems, there is non-compliance, they will ask the submitter to redesign and resubmit. That decision by the jurisdiction is typically subject to an appeal. If the applicant wins the appeal, he gets a permit. If he loses the appeal, then he has to redesign and resubmit. And then it is the same as before. If the resubmitted drawings and calculations are in compliance, you will get a permit. If they are not in compliance, they will have to come back. Okay. So this part of enforcement depends on the ability of the jurisdiction to do a proper plan check. I do want to emphasize that. Now, we found that there is no fire safety plan review for residential buildings up to 6 stories in height in Bangladesh. Residential buildings up to 6 stories in height may have 500 people in one building sleeping at night. No fire safety plan review for those buildings. Not even indirect requirement to meet BNBC fire safety requirements. This we thought was a so-called gaping hole. Second part of enforcement, we talked about design. Now you have a permit, so now it is construction. Construction has to be inspected. The inspectors have to make sure that the construction is in accordance with code requirements. If that is so, then the inspector will so declare, and the applicant will get what is called a certificate of occupancy. Then he can go ahead and use the building for whatever purpose the building was erected. If, however, the inspectors detect that there are violations of the code, then a certificate of occupancy will be denied, and then they will have to rectify all the problems that have been found and go back to the jurisdiction and get a certificate of occupancy. So this inspection is also a very integral part of code enforcement. We found that there is no fire safety inspection for residential buildings up to 6 stories in height in Bangladesh, or at least in Rajuk jurisdiction. So we have made a whole lot of recommendations in our enforcement program report for project S9. One volume of this 4-volume report has the recommendations only. I think the recommendations are written in understandable terms, and two of the major recommendations concern plan review and inspection of structures. Both cases we have seen in view of, Rajuk's limited manpower and resources, third-party plan checkers and third-party inspectors should be employed to enhance the process. The third-party plan checkers and inspectors will be an extension of Rajuk. They will have no power of their own that is not delegated by Rajuk. Okay. So we have elaborated on every aspect of our recommendation, and I will leave it at that. This first part of the presentation, I think this is where I will conclude. Okay. The second part, let me go to another. The second part today was supposed to be delivered by Professor Rakib Hassan. He unfortunately is a bit under the weather, so I told him that he shouldn't make his situation worse by trying to speak today. So I will try to handle his part. It will not be as good as if he had delivered it, but let me see. I believe Professor Dr. Rakib is in attendance. If I mess up, he can step in. And also at the end of this segment, we will have a question and answer session. And I have asked Dr. Rakib to be available for that session so that he can answer the questions that I cannot. So this is about the way we will do it. From a general overview of building codes, we are now going to an overview of BNBC 2020 in particular. Okay, so you have seen this picture a couple times now. This is the code that we will talk about very specifically, BNBC 2020, gazetted in February of 2021. Okay. Evolution of building codes. Hammurabi's code has been mentioned. That obviously is ancient times. In more modern times, the first record, maybe not the first, but one of the first records we have is after the Great Fire of London in 1666, the Rebuilding of London Act was passed, and that was like a building code, one of the first ones that we are aware of. In the United States, the city of Baltimore was among the first to pass a building code in 1859. That's definitely not ancient times. That's not even 300 years now. But that's the first in the US. That was just one city in the country. In 1905, a US insurance group, the National Board of Fire Underwriters, created a document called the National Building Code. When I arrived at the Portland Cement Association in the mid 70s, there was a copy of this document around. I think it was the 1970 edition, something like that. There was a picture of the United States. There was a map of the United States on the cover. The document, this document was updated every 10 or 15 years. I don't know, mainly because of that, it died a natural death by the 80s. A different system of building codes had evolved in the United States. This started in 1915 when the Building Officials and Code Administrators International, BOCA for short, was formed. 1915. This is a so-called model code group. They published the first so-called basic building code in 1950, and this basic building code became the BOCA National Building Code starting somewhere in the 80s after the original National Building Code died. So National Building Code issued by the National Board of Fire Underwriters was discontinued. BOCA took up that name, National Building Code, but to distinguish their code from the original National Building Code, they started calling it BOCA/National Building Code. And that's how it was known until its last edition dated 1999. The second model code group, International Conference of Building Officials, was founded in 1922. So the first one in 15, second in 22. They published the Uniform Building Code in 1927. That was the code adopted by, let us say, roughly half the western half of the United States. And because the seismic design provisions of this code were supposed to be kind of state of the art, this document, this code had very significant worldwide influence. I should say continues to have. There are places in the world where they still swear by. You go to Iran, that's pretty much the same, pretty much the story today, that the uniform building code. Okay. With all the fighting with the US and so forth, that the code that they are they are wedded to is the uniform building code. So the Boca Building Code was adopted roughly in the south, in the northeastern quarter of the country. The Uniform Building Code in the western half of the country. Then there was a third model code group, the youngest one, formed in 1940, called the Southern Building Code Congress International. And they issued their first code called the Standard Building Code in 1945. This was adopted, roughly speaking, in the southeastern quarter of the United States. And because wind is a huge problem in the Gulf states and the Atlantic states, the wind design provisions of this code were pretty strong. The Standard Building Code. The three model code groups, the BOCA, ICBO, and SBCCI, merged in 1994 to form the International Code Council, ICC, that you all know about. And ICC published the first international building code in the year 2000. Okay, now there is a family, of course, not just the building code. There is a plumbing code, mechanical code, fire code, etc., as you know. But anyway, so the organization is the International Code Council, which is which resulted from the merger of the three regional model code groups. And the code is International Building Code, International Fire Code, and so forth. Building code in Bangladesh. The Building Construction Act of Bangladesh was enacted in 1952. This has a history going back from the colonial days. The first building code was drafted, so that is an act. The first building code was drafted in 1993 by the Housing and Building Research Institute. The Building Construction Act of 1952 was amended in 2006 to empower the government to promulgate the Bangladesh National Building Code. This is 20. So the code was drafted in 93, 2006 came the legal underpinning. BNBC was enacted through a statutory regulatory order, whatever that means, in 2006. So the first national building code became legal in 2006. Housing and Building Research Institute undertook BNBC update project in 2009. Final version of the updated code was submitted for approvals in 2015. It was approved by the steering committee, the Ministry of Housing and Public Works, headed by the Law Ministry, but the final approval somehow took an incredible amount of time until in February of 21, the document was gazetted and it has been called the 2020 edition of BNBC, although I do not believe from 1917 onwards the document has been touched. Be that as it may, so the 2020 edition is the second edition of the Bangladesh National Building Code. gazetted less than a year ago. At the same time, this is the only time I will throw this in. This code, because it was started in 2009, is already outdated in many ways and badly needs updating in certain areas, which effort should get underway hopefully soon. The purpose of the BNBC is to establish minimum standards for design, construction, quality of materials, use and occupancy, location and maintenance of all buildings within Bangladesh in order to safeguard life, limb, health, property, and public welfare. Building code is not meant for general public. This is important. A building code is not printed for just anybody to read. Okay, this is not something you take to bed to read before sleep comes to you. It's not that kind of a document. Building code is written for professionals, and it's like law books or medical books. Unless you have a certain background, it will not mean much to you, and that needs to be kept in mind. Okay, so it is the building code is written for professionals with a certain background. Definition of building: any permanent or semi-permanent structure which is constructed or erected for human habitation or for any other purpose, and includes but is not limited to the foundation, plinth, walls, floors, roofs, stairs, chimneys, fixed platform, veranda, balcony, cornice, projections, extensions, annexes, etc. A few of Dr. Rakib's slide I have modified. This one I have not modified. This is the exact language he had there. It is probably taken from BNBC. Anyway, so, and then also building also includes the sanitary, plumbing, electrical, HVAC, appurtenances, and all other building service installations which are constructed or erected as an integral part of the structure. So all of that is building. Now here we make a distinction between buildings and non-building structures that I will not go into right now. So this definition of building will pretty much include non-building structures as I read it. BNBC, I think all of you know, is in 3 volumes. Volume 1 has parts 1 through 5. Part 1 is scope and definition. Part 2, administration and enforcement. Very important part of the code, not to be minimized. People see administration and enforcement, they move on, but that is not the right thing to do. So this part 2 really needs to be read and understood. Part 3, general building requirements, control and regulation. Part 4, very importantly, is fire protection. Part 5, building materials as opposed to design using building materials. Okay, building materials themselves. Volume 2, all of Volume 2 is just Part 6, structural design. I should not say just Part 6. That is a huge part that talks about structural design in all the materials that are allowed to be used in buildings. Then Part 3 has, not Part 3, Volume 3 has Parts 7, 8, 9, and 10. 7 is construction practices and safety. Part 8 is building services that we were talking about, electrical, mechanical, energy, all of that. Part 9, very importantly, addition, alteration to, and change of use of existing buildings. And Part 10 are signs and outdoor display. Yeah, in US code, signs and outdoor display are not given this kind of treatment, full treatment. I looked into it at one time. I believe that this is modeled after the Indian code, and it does make sense. But this part is kind of different from what you will see in US codes. Okay, part two, administration and enforcement. The part that I said is quite important. Part two has 3 chapters: purpose and applicability, establishment of authority, etc. This stuff is important. Permit and inspection. Under establishment of authority, BNBC says the government may establish the Bangladesh Building Regulatory Authority, BBRA. That has not happened, but the code gives provision for this. BBRA may establish. The authority shall consist of the following 5 members, which we have not gone into in the slide. The authority, BBRA, shall designate specific geographical jurisdiction as the office of the building official. So Rajuk would be, for instance, the office of the building official. The building official shall exercise his power and responsibilities through a building construction committee. That's how it works at Rajuk and the other authorities that we have been familiar with. The authority may constitute a board of appeal to hear and decide appeals of orders, decisions, or determinations made by the building officials. So the authority may constitute a board of appeal to hear and decide appeals of orders, decisions, or determination made by the building officials. So the building officials' call is not final. It is subject to appeal by this board of appeal. Jurisdiction of building officials. Remember, the language was BBRA. The authority shall designate specific geographical jurisdiction as the office of the building official. So this is where this list comes in. Areas under the master plan of Rajuk, the authority is Rajuk. Areas under the master plan of Chittagong Development Authority, the Chittagong Development Authority is the authority. Similarly with Rajshahi Development Authority, with Khulna Development Authority. Areas under any development authority, the relevant development authority is the authority, or that is the office of the building official. Areas under any city corporation, the authority is the city corporation. Areas under any municipality, the municipality is the jurisdiction. Areas not falling under any of the above, very, very importantly, office of the executive engineer of PWD is the authority. Okay, where there is no development authority, corporation, or municipality, the office of the executive engineer of PWD is the authority. Special areas, if any, to be declared by then the government decides case by case who the authority would be. Types of permits and building categories. So first of all, the permits. There are a number of permits depending upon the structure that may have to be taken out. Land use certificate. Validity of that certificate is 24 months. You have to do something on the land within that period. Otherwise, the certificate lapses and you have to take out another one. Rajuk is supposed to, upon proper application, Rajuk is supposed to give it to you within 15 days. Large and specialized project permit, validity 24 months, time that Rajuk has to process and and issue it to you 45 days. Building permit validity 36 months. So this permit without which you cannot construct is valid for 36 months. If you don't do anything in that time, then it lapses. And Rajuk has 45 days to process the application and issue the permit. Occupancy certificate has perpetual validity, although I think it has to be renewed every 5 years. I believe is the case, or maybe it is our proposal, and a little bit. Anyway, so the time that Rajuk has to issue it is 15 days. BNBC in a table, I believe it is 2.3.3, something like that, has these building categories defined. Category 1 is up to 2 stories in height, up to 250 square meters in floor area. Category 2 up to 5 stories and 1,000 square meters. Category 3 up to 10 stories and 7,500 square meters. Category 4, very importantly, is any height, any size. Category 4. Okay. So then BNBC very importantly gives you this table where it spells out the professionals that can do certain things and how much experience that professional has to have. So if it is a survey, a diploma engineer can do the survey for category 1 buildings up to 2 stories and thousands, what was it, 2 stories and how many square meters? 2 stories and 250 square meters. There are really no requirements, experience requirements for the professional. But if it is a category 2 building, the diploma engineer has to have 3 years experience. And for category 3 and 4, the 3 years remains unchanged. Soil testing can be done by a civil engineer. For category 2 buildings, 2 years of experience, but for category 4 buildings, unlimited height, unlimited area, 5 years of experience. Structural design has to be done by a civil engineer, 2 years experience in the case of category 2 buildings, 4 years experience in the case of category 3 buildings, 8 years experience in the case of category 4 buildings. So you get the idea. This type of a table is definitely not in any US code, but I think this serves a very, very good purpose. Okay, so everything is spelled out, and this is the table number is not on the slide, but this is a table directly in BNBC 2020. For many things, a building permit is not needed, mainly because they are really not buildings. Railways, national highways, national waterways, national gas grid, national power grid, major ports, airways and aerodromes, telecommunications, the towers and so forth, electronic broadcasting services, any other services which the government may declare to be essential to the community. Responsibilities of the owner. This is spelled out in BNBC. Some of this stuff is kind of important. The owner shall be responsible for carrying out the work in conformity with this code. Okay, that's the owner's responsibility. The owner is ultimately responsible for code compliance. It's not the people that the owner hires. Design, execution, and supervision work shall be carried out by authorized registered professionals. Owner shall allow the building official to enter the premises. This is required. This is his responsibility. The owner shall obtain permit as may be applicable. That again is owner's responsibility. The owner shall inform the building official about attainment of construction work at different stages, like stage by stage completion kind of thing. Should keep the building department appraised. The owner shall take proper safety measures, very, very important. The owner shall notify the building official of the completion of the work. The owner shall preserve at the site a copy of all permits. Where the live load exceeds 2.4 kilonewton per square meter, designed live load shall be conspicuously posted. This is a code requirement. Heavy live loads. Unsafe buildings. All buildings that constitute danger to public safety or public property shall be declared unsafe by the building official. In case the owner fails, neglects, or refuses to carry out the repair or improvement of an unsafe building, the building official shall cause the danger to be removed either by demolition or repair, the cost of which shall be borne by the owner. Okay, so these are pretty significant powers being given to the building official, as you notice. Now, this results in litigation and all kinds of things, but building official does have the power. If the building official determines that an unsafe building constitutes imminent danger, the building official shall at once cause such building to be rendered safe or removed. I think this kind of power to be given by the building official makes a lot of sense. This is public safety. At the same time, you know, this kind of determination is not easy, and these things tend to get messy. The building official may also get the adjacent structures vacated and protect the public by an appropriate fence. Architectural and environmental control. This slide I didn't modify, but I think you need to read from the bottom line first. So the authority, which should be the jurisdiction, in our case, let's say Rajuk, shall appoint a standing committee comprising noted experts, essentially to exercise architectural and environmental control over these structures. Major public building complexes, buildings in the vicinity of monuments and major sculptures, buildings near architecturally valuable structures, buildings near historic buildings, buildings near structures that represent the special characteristics of an area, buildings that represent special characteristics, any development that may have effect on the environment. So the authority shall appoint a standing committee comprising noted experts to exercise architectural and environmental control over all the structures that are listed on this slide. Okay, we come to part 3, which is general building requirements, control, and regulation. Chapter 1 of part 3 is general building requirements. Chapter 2 of part 3 is classification of buildings based on occupancy. This tends to be very important for many things you need to do. Also, classification of building construction type based on fire resistance, and then energy efficiency and sustainability. So occupancy classification based on, not occupancy classification based on, classification of buildings based on occupancy. That's what we are talking about here. So residential buildings, that would be type A, educational buildings, institution for care, healthcare facilities, business occupancy, mercantile, industrial buildings, storage buildings, assembly buildings, hazardous buildings, garages, utility, miscellaneous. Okay, so those are the classifications based on occupancy, and depending upon what classification you have, you may be subject to different regulations in the code. Classification of building construction based on fire resistance. So there is non-combustible and combustible, group 1 and group 2. 1A is 4-hour fire rating, fire protected. 1B is 3-hour fire protected. So 1A is the highest resistance to fire, and 1E is unprotected. In the combustible division, 2A, as you see, is heavy timber, then protected wood joist, unprotected wood joist, protected wood frame. Unprotected wood frame is 2E. So anyway, gives you an idea. This is classification based on fire resistance. Okay, non-combustible is group 1, combustible is group 2. In non-combustible, the fire rating dictates the type. 1A is the highest, 1E is unprotected. Other architectural issues covered: requirements for plots, drainage, etc., plot sizes, means of access, open spaces within a plot, which would include setbacks, ground coverage, etc. General height and area limitations, the floor area ratio falls under that. Off-street parking spaces, street encroachment, community open space and amenities, minimum standard of a dwelling, requirements of parts of buildings, landscaping, dam proofing and waterproofing. Okay, all of that is covered in BNBC 2020, which is a pretty comprehensive document. Energy efficiency and sustainability. All kinds of things are popping up all the time. So energy efficiency and sustainability, the scope includes incorporate building concepts having a positive environmental impact and encourage sustainable construction practices, allowing efficiency and conservation of energy, water, and building materials, and to promote resource efficiency. It's kind of a complicated sentence, but it tells you quite a bit. So incorporate building concepts having a positive environmental impact. That's understandable as it is. Encourage sustainable construction practices, allowing efficiency and conservation of energy, water, and building materials, and to promote resource efficiency. The efficiency may have been said one too many times, but you get the idea. Then site sustainability is covered in BNBC. Building envelope, that is a huge subject. Building envelope has to keep the weather out. Water must not get in. All of these things are much easier said than done. Energy efficient building systems, internal water management. It just the list give you an idea of how many things are involved in a building. So fire protection, we didn't in this slide set, or Dr. Rakib didn't go into details, but these are the topics covered. And some of these are huge topics, means of egress, for instance. Anyway, so in part 4, we have chapter 1, general provisions, chapter 2, precautionary requirements, chapter 3, means of egress, Chapter 4, Equipment and Inbuilt Facility Standards. Chapter 5, Specific Requirements for Fire Detection and Extinguishing System. So pretty comprehensive requirements, although this may not be the most comprehensive if you look at codes of the United States and so forth. Building materials, part 5, very important, and this is very instructive. How much is covered? When I say covered, this is specifically covered in BNBC 2020. You have sections, you have provisions, you have requirements. So, building materials covered: masonry, cement and concrete. Pre-stressed concrete is somehow separated from concrete, which I find interesting. Building limes. This should not be a material in the US separately. It is part of masonry. The Portland cement, lime, mortar. Anyway, so building limes, gypsum-based materials and plaster, flooring materials, steel, timber and wood products, doors, windows, and ventilators, aluminum and aluminum alloys, builders' hardware, roof coverings, paints and varnishes, sanitary appliances and water fittings, miscellaneous materials, CGI sheet, I don't even know what that is, roofing and walling. Anyway, this is much more comprehensive than in any US code. I think you should be very happy that there is so much coverage, specific coverage of detailed topics, and I will leave it at that. Obviously, these things need to be updated. That's the problem, because things keep on changing. Volume 2, as I mentioned, the entire volume has one part, part 6, on structural design. And that is a huge topic. People like me, that's the part we deal with. Okay, structural design, part 6. Chapter 1 is definition and general requirements. Everything here is important. 2, loads on buildings and structures. That is a huge topic. Here you have the live loads on structures specified, wind loads, which is a topic unto itself, the design earthquake forces that you will use in your design, all of that is in this chapter 2. Okay, chapter 3, soils and foundations, huge topic. Chapter 4, bamboo. Chapter 5, bamboo is something I don't know anything about, and I haven't frankly bothered to read that chapter, but anyway, it's there. Concrete material, chapter 5, concrete material, not the design requirements. The strength design of reinforced concrete structures is chapter 6. That chapter, I will have several lectures basically on that. Masonry structures, chapter 7. Detailing of reinforced concrete structures. I find it interesting that it's a separate chapter. This is where the seismic detailing is, and also what I would loosely call non-seismic detailing. So chapter 8. Pre-stressed concrete is a separate chapter 9. Steel, chapter 10. Timber, chapter 11. Ferrocement, chapter 12. That is not in US codes. And then steel, concrete, composite structural members. How much of that is built, I don't quite know. But there's a chapter 13 on that. Volume 3, the last of 3 volumes, has the construction practices and safety requirements in part 7. The chapters in there, construction practices and safety, are constructional responsibilities and practices, storage, stacking, and handling practices, safety during construction. This is extremely important stuff. In the US, there is a federal agency, OSHA, that takes care of some of this. Building code has the rest of it. In Bangladesh, the entire regulations are in BNBC. To what extent they are being enforced, I don't exactly know. We do not have a clear picture, I should say. But anyway, these are all very important topics. Safety during construction, without which the workers are in trouble. This has been historically a problem in countries around the world. Okay, things have improved, but more improvements are always necessary. So, construction responsibilities and practices, storage, stacking, and handling practices, safety during construction, demolition work should that be needed, maintenance, management, repairs, retrofitting, and strengthening of buildings. The retrofitting and strengthening part is not is far from comprehensive, but there are some things said in chapter 5. Building services, part 8. This is a world unto itself, okay, which structural engineers know very little about. Electrical and electronic engineering services for buildings, air conditioning, heating, ventilation, building acoustics, lifts, escalators, moving walks, water supply, sanitary drainage, rainwater management, fuel and gas supply, electrical building services, lighting. We are listing these topics because these are covered in the code. I hope you keep that in mind, that we have code provisions that will govern the installation of lighting. So lighting, load estimation, fitting fixtures and accessories, wiring, substation and transformer, distribution system, switch and switchboards, overcurrent and short circuit protection, fire protection, alarm and emergency lighting, earthing, lightning protection, telecommunication, CCTV and access control system. HVAC, this is heating, ventilation, and air conditioning. So there is planning requirements, air conditioning system design, air distribution system, air conditioning equipment, refrigerating equipment, ventilation system, energy conservation, inspection, testing, and commissioning, operation and maintenance. I know that this kind of reading of list is boring, but I hope that for a structural engineer or a civil engineer, this is in itself very good exposure to what the other professionals deal with, the electrical engineer, the mechanical engineer, all of whom have a role to play in the construction of a building. So this is what they're dealing with. Acoustics, in depending upon the occupancy of the structure, this can be very important. Obviously, if a building is for performances, by artists, acoustics is one of the most important design criteria. Anyway, so under this chapter, classification, planning, design, speech privacy, and sound amplification system. Topics concerning lifts and escalators, safety considerations, design considerations, escalators, moving walks, energy conservation, inspection and certification, operation and maintenance. All of that is dealt with in the code. Types of water supply. So there is permitting involved, licensing of plumbers, water supply requirements, estimation of demand load, water resources and quality, inspection and certification, water supply system, storage of water, design of distribution system, water distribution in tall buildings, which has its own challenges. Obviously, you have to pump it up long distances. Hot water supply installation. I do not know how common it is in Bangladesh, but hot water is definitely needed for anyhow. Yeah, pipe work, cleaning and disinfection. Sanitary drainage, again, planning is involved, licensing of plumbers, drainage and sanitation requirements, materials and appliances, design considerations, refuse chute system, basement floor drainage system, healthcare drainage system, inspection, testing, and completion certificate guide to maintenance. The last number of slides simply gives you an idea of the scope of BNBC, how comprehensive a code it is, and the stuff that it deals with. Rainwater harvesting, for instance. It is becoming increasingly important, conservation of resources, and it is pretty remarkable that the code has specific provisions concerning that. So rainwater harvesting requirements, rainwater harvesting planning, licensing of plumber, rooftop rainwater harvesting is treated separately, artificial groundwater recharge, drainage and sanitation requirement, materials and appliances, construction, inspection, testing, and completion certificate, guide to maintenance. And then fuel and gas supply, the gas piping installation, use of this liquid petroleum gas, and installation of appliances. Then the very important topics of alteration, addition to, and change of use of existing buildings. Not a lot is laid on the slides, but please pay close attention. This is very, very important stuff. Okay, alteration, addition to, and change of use of existing buildings. So chapter 1 deals with applicability and implementation. Chapter 2 deals with evaluation and compliance. Chapter 3 deals with, very interestingly, conservation. You don't find that in too many codes, this topic of conservation. So applicability of the provisions. No change in use shall be made without permission from the permitting authority. This is extremely, extremely important. Okay, so you need a permit from Rajuk to do a change of use of your building. You cannot do it on your own. No change in use shall be made without permission from the permitting authority. No addition shall be made without permission from the permitting authority. First was change of use, second is addition. An existing building shall not be altered in such a manner that results in the building being less safe or less sanitary. So an existing building shall not be altered in such a manner that results in the building being less safe or less sanitary. Any construction which does not have approval of the appropriate authority must be removed before any new addition, alteration, or change of use. Okay, I'll read it again. Any construction which does not have approval of the appropriate authority must be removed before any addition, alteration, or change of use. So everything said on this page I consider to be highly, highly important. For the proposed works relating to alteration, addition to, and change of use, the owner of the building shall cause the existing buildings to be investigated and evaluated by competent professionals. This is extremely important. I could not overemphasize the importance of this evaluation. So for the proposed work relating to alteration, addition to, and change of use, the owner of the building shall cause the existing buildings to be investigated and evaluated by competent professionals. Very important. The results of the investigation and evaluation shall be submitted to the building official. The building official shall determine whether the proposed additions, alterations, change of use complies with the provisions specified in this code, meaning BNBC 2020. Conservation. As I said, not very common in codes, but BNBC has conservation in it. Conservation is the process of retention of existing buildings or groups of buildings, landscapes, etc., and taking care not to alter or destroy character or detail, even though repairs or changes may be necessary. This is very important. So you need repairs, otherwise things decay and just disintegrate. But conservation means that you try not to change the character. That's conservation. Process of retention of existing buildings or group of buildings, landscaping, etc., taking care not to alter or destroy character or detail. That's okay. Restoration, that is conservation. Restoration is the process of carrying on alterations and repairs to a building with the intention of restoring it to its original form. It is generally regarded as more drastic than conservation. It definitely is more drastic than conservation. Okay, conservation, you don't try to do too much. Restoration is the process of carrying on alterations and repairs to a building with the intention of restoring it to its original form. Guidelines to conservation. Be reversible and repeatable. The reversible part, so you need to paint a part of a building. You try to paint it, you try to make the paint look as close as possible to the original paint. Now, how are you going to reverse it if it turns out to be more different than, but that's the idea. To the extent that you can reverse it, that is to be aimed for. And repeatable, meaning you should be able to do the same thing. Like another wall needs painting, you should be able to repeat what you did to the first wall. Not prejudice a future intervention. That's kind of important. Whatever you do, if more needs to be done to the structure at a future date, you should not make that difficult by your conservation measures. Not hinder the possibility of later access to all evidence. Evidence meaning, what might have happened by way of deterioration, cracking, this, that. You shouldn't hide those things. Allow the maximum amount of existing material. Be harmonious in color, tone, texture, form, and scale. All that makes sense. That's conservation. Harmonious in color, tone, texture, form, and scale. Not be undertaken by a conservator who are insufficiently trained. That is extremely important. Okay, it's very easy to mess things up. So adequately trained is a must. Science and outdoor display, the last part. Chapter 1 is scope and general. Chapter 2 is general requirements. Chapter 3, specific requirements of various types of signs. So a written permit shall be obtained from the authority if you want to put up a sign, but there are exemptions from that. Wall signs, shop signs, building names, nameplates, etc. Group sign, grounds, ground signs, official warning signs, direction indicators, etc. Temporary signs, construction signs, displays for festivities, etc. So those do not require permits. Unsafe and unlawful signs, it shall be the responsibility of the owner to ensure the safety and legality of the sign. That probably goes without saying. Restrictions on signs and outdoor displays. So restricted sign zone, that there may be restricted sign zones designated. Prohibition and advertisement. Prohibition on advertisement. If there is prohibition, you obviously cannot violate that. Signs on highways and roads, there are restrictions on what you can and cannot do. Illuminated displays, again, there are restrictions. Location restrictions. Projection over public property, that obviously should be restricted. And clearance from power lines, that is extremely, extremely important. Specific requirements of various types of signs that are given in BNBC 2020: electric signs, ground signs, roof signs, projecting signs, fin signs, I don't even know what they are, balcony signs, marquee signs. That brings us to an end. So again, the second part was material prepared by Dr. Rakib. I did make some modifications here and there. Anyway, as I said, Dr. Raki would have done it better, but under the circumstances, I thought I would do it. Okay, I think we are, it seems to me that we are early. Anyhow, we are open to question. I hope Dr. Rakib is here. I would invite him to join in the answers. We did not. Bodhi, are there questions in the Q&A folder, or how do we?
Yeah, let me. So everyone who wish to ask a question, you can go to the Q&A panel. That will be to the bottom right of your screen. If you are on the full screen mode, then you have to exit the full screen mode, and then you can access the Q&A section to the bottom right of the screen. Just press on that button and select a speaker and ask a question, or you can select the host and ask a question. And Dr. Rakib, I have already made you a co-host. You can unmute yourself and you can talk. You can speak right now.
Dr. Rakib, if you want to add anything to anything I said.
Dr. Rakib? We are not able to hear you. I see that you unmuted yourself, but we are not able to hear you. Yeah, maybe he is having some audio problems on his side.
Are there questions?
I don't see it on my panel. Do you see it on your panel, Dr. Ghosh?
No.
Okay. Okay. So there is one question.
Okay, can you
So,
read to me?
okay. Just a second. So what is the difference between durability and sustainability, which is stated in the code evaluation?
Yeah, durability and sustainability are pretty different things. Durability is how long something is going to last in uh, last meaning not just stand up there but be serviceable. Okay, so I don't know how. So we sometimes talk about a 50-year service life for a structure, but if somebody wants to put up a monument of some kind, he or she may want 100-year service life or maybe 200-year service life. Then we need a higher level of durability. Now, durability has the main parts of durability are the concrete uh, must not crack and spoil, must remain intact. The reinforcement must not corrode and cause problems. So there is concrete durability, there is reinforcing steel durability. Concrete durability has major aspects. In this country, freeze-thaw resistance is a problem which it doesn't exist in Bangladesh. From that point of view, you are lucky. There is sulfate in the soil that can destroy concrete in a big way. That has to be considered. Chlorides in the air or water can eat away at reinforcement. So chlorides need to be kept within limit. And in general, higher strength concrete is denser and therefore more watertight. And the water cementitious materials ratio tends to be pretty important. The lower the water cementitious materials ratio, the more watertight the concrete and more durable it is. So durability is for a concrete member to remain intact for a considerable period of time. It's like longevity of a human being. That's what durability is. Sustainability, on the other hand, is conservation of resources. Let us say you build a concrete structure. Cement, which is a major ingredient of the concrete, is very energy intensive. To produce cement costs a lot of energy. Fly ash, on the other hand, is a byproduct of coal burning. It essentially comes for free. If you replace 25% of the cement that you're going to use in concrete with fly ash, you have conserved a lot of energy. You have replaced a material that uh, requires a lot of energy to produce with a material that comes for free. That is a byproduct of another process. And you have made your concrete more sustainable. Okay? So from this is probably not the best example, but you understand sustainability is about renewal. You do not use up resources that have to be replaced. When it comes to energy, okay, if your electricity is being generated by burning coal, that is not sustainable energy. If your energy is coming from sunlight, all these solar panels that are being installed these days on roofs, that is sustainable energy. You are not using up non-renewable resources. Okay, so that was a bit of a rambling answer, but I hope that you got your answer: durability and sustainability. Okay, any other questions, Bodhi, that you can read to me?
Yeah, I will assign it to you also, and so you can also read it. At the same time, I will just read out the question.
Any other question?
Yeah, so I would like to draw your attention to the Appendix C, page 4196, BNBC 2020. Some seismic parameters have been considered. My question is, without response spectrum graph, how the parameters could be used? He also provided a suggestion to improve the appendix with the criteria given by the source documents like ASTO LRFD to 2017. So I
Good.
think the question is very specific.
Yeah, this kind of a question I cannot answer now, but we will look at we have 8 seismic modules coming up. And before the right, and I have one module specifically on, I have called it seismic design using dynamic analysis. There we will talk about this modal response spectrum analysis. And maybe your question pertains to that. We will take a look at the appendix, your question, and hopefully provide an answer on that day.
So the next question is, what are the major changes from previous BNBC? So that is a very general question.
Yeah, okay.
Yeah,
So
I will.
it
Do you
is,
want to answer this or should I go to the next?
say that again.
Do you want to answer this question or should I go to
Yes,
the next?
I will try to answer. Yes,
Yeah,
yes, very
okay.
definitely. Uh, so as Bodhi said, it is a it's a very broad question, and I obviously cannot give you detailed answer, but the answer that I would like to give you is the previous code that was dated 2006, the first edition of BNBC, was basically I don't know if completed is the right word. The work was done in 1993. That date is important. Okay. So in 1993, the ACI 318 edition was 31889. There was a revised 92 edition. I do not know, but let us say it was ACI 31889. BNBC 2020, on the other hand, was started in 2009. So the ACI 318 edition adopted by that is ACI 31808. Okay. So just for concrete construction, to give you an example, we are going from ACI 31889 to ACI 31808. ACI 31889, as I said, was followed by ACI 31889 revised 92, then ACI 31895, then 95, then ACI 31899, then ACI 31805, then ACI 31808. So we are looking at all the changes made in ACI 318 over 5 editions of that document. Okay. So I hope what I'm trying to say is registering that you are appreciating the amount of change that entails. Okay. AC7, the major standard from which all the loads are taken. In BNBC 2020, which was started in, as I said, 2008 or 9, the AC 7 edition adopted its AC 705. Back in 1993, I have to remember now, it was ACE 7. I'm looking at my shelf. I don't remember that. 1 second, I'll tell you. So in the 2006 BNBC, which was started in 93, AC 7 edition had to be AC 788. So AC 788 to AC 705, there were additions in between, and I can tell you that the changes are enormous in wind, in seismic. So so that is not a complete answer to your question, but that gives you an idea of how different those documents are.
Okay, Dr. Ghosh, thank you. So the next question is that is related to BNBC. Today's webinar is a garment building was constructed supposed to be complying BNBC 2006. Now BNBC 2020 is enforced. The owner wants to conduct detailed engineering assessment. Which code, BNBC 2020 or 2006, should be followed for analysis and retrofitting?
Read the question again.
A garment building was constructed and it was supposed to be complying to BNBC 2006. Now that BNBC 2020 is enforced and the owner wants to conduct detailed engineering assessment, which code, BNBC 2020 or 2006, should be followed for analysis and retrofitting?
Analysis is not I anyway, I do not see if the owner wants it evaluated, I assume that he wants to know what it would take to update it to the new code dated 2020. That should be the purpose of the evaluation. Otherwise, I do not see, I mean, why would he want to know whether the building complies with BNBC 2006 in 2021? So I am not
No,
sure.
no, no. The question, it means that the garment building which was made, which was built at that time, maybe it was built using like it was built by complying to BNBC 2006 code. So now that they are doing the rehabilitation, so and now that they just want to see if the building is in right condition or not. So should they be Should they like check it by complying to the newest code or complying to the code that was used while it was constructed? So that is what he's asking, he's trying to ask.
Yeah, I guess the question is not particularly clear to me. The only answer I can give you is, as I pointed out repeatedly, it depends on what the owner wants to do to the building. If it is an addition that he wants to make, it will depend on the extent of the addition, whether it is okay to comply with the old code or whether the addition itself will have to comply with the new code, no question, but the entire building may have to comply with the new code if the addition is large. If there is a change of use, then you will have to comply with the new code. If there is alteration and depending upon the extent of the alteration, the altered building may have to comply with the new code. So to give you a general answer is not going to be possible without knowing exactly what is being proposed to be done. Just saying retrofit does not tell me enough to answer your question, I guess.
Yeah, I think the answer you gave is pretty clear, Dr. Ghosh.
Okay.
Uh, yeah, there are a number of questions regarding S.Eng and like S.Eng training in general and S.Eng exam. So I would recommend all of you guys to go to the PRP portal, and there is a link right on the home page that gives you a brief idea of this entire program and what it is supposed to do and how you are going to be eligible for the exams and stuff. So I would just recommend you guys to go there and uh, check for yourself. So the other question is related to the webinar. What should be the ideal design life of building if BNBC followed minimum? So yeah, the question is framed kind of in a good way.
I do not know if there is a definite answer to that question. Maybe Dr. Rakib has an answer, but we typically assume the service life of a building to be about 50 years. This is typical expectation. That's all I'm going to say. If you comply with BNBC 2020, you should expect a service life of no less than 50 years. Obviously, if it turns out more, it is fine, but it should not be less than 50. This is not written any place, but this has been our expectation over the years. Is Dr. Rakib connected or no?
He is connected. He's unmuted too, but I don't know.
He cannot hear him?
We still cannot hear. Yeah,
That's a shame. Yeah.
I think there is some audio issues on his side, so that needs to be fixed later, I guess.
Yeah.
Okay. So Dr. Ghosh, so next question.
Yeah.
Say the new code is in effect and existing building needs to be evaluated according to the code in effect. How will the live loads be considered? Can we use the old code's live load, or should it be strictly followed as per the new code? In addition, if the live loads can be measured, can that be used for analysis which is less than the new code's live load but greater than the old code? So it is kind of related to what you answered before.
You have to read it again, please.
Okay. I have assigned that question to you too, Dr. So you can also read it on your question answer box.
I am not able to read very well somehow. I don't know.
Okay, so I will read it again. Say the new code is in effect and the existing building needs to be evaluated according to the code in effect. How will the live loads be considered? Can we use the old code's live load, or should it strictly follow as per the new code? In addition, if the live loads can be measured, can that be used for analysis which is less than the new code's live load but greater than the old code?
I see. Yeah, so there are two questions. One is, yeah, so if you are evaluating by the new code, everything has to come from the new code. And if the live load has gone up, it's too bad. That's what you have to consider. Now, the second part of your question is if you are somehow able to determine the live load, and if that is less than the code prescribed value, are you less than the value prescribed in the new code, are you allowed to use it? I have never seen that done. I don't even know how you determine the live load for a building. I do not know. So my answer would be no, go with the code value. But if there is a specific provision in BNBC that allows that, maybe I don't know about it. So, but this is generally this as I said, I have never seen done. To determine live loads on a structure is not. I wouldn't even know how you would do it. You know, it's a statistical thing. You have to observe for a long time and figure out. So I personally wouldn't go there. My answer would be use the live load in the updated code, whatever the value might be.
That answers the question, Dr. Ghosh.
Mhm.
Okay. So the next one is why BNBC 2020 didn't include aluminum structure, and how do we analyze aluminum structure? So
Yeah, why it doesn't include aluminum, I don't know. Probably because there isn't much use. But if you want to do something with aluminum, uh, IBC has a very brief chapter, half a page, that refers you to two documents issued by the aluminum industry. So that would be, I think, your best source, at least to start from there. And we let me see. We have the email address of the questioner, Bodhi.
I have the name. So I can find out the email address. Yeah.
Okay. We can send the references.
Okay. Okay.
Yeah. So
Okay, Dr. Ghosh, yeah.
mhm.
Sounds good. The next question. Okay, there are a lot of questions related to evaluation of buildings, so that you have already answered. So I'm not going
Mhm.
over those questions.
Mhm.
So if we design an industrial building
Mhm.
as per BNBC 2020, table 3.2.1, fire resistance, no industrial building can permit any assembly area like canteen or prayers. Then how to design building having different occupancy?
Read that again.
If we design an industrial building
Mhm.
as per BNBC 2020 table 3.2.1, fire resistance,
Mhm.
no industrial building can permit any assembly area like canteen or for prayers. Then how to design building having different occupancy?
This one I cannot answer without looking at the
Dr. Rakib would have been.
regulations. Yeah, maybe, yeah, it's a. So this one between Dr. Rakib and me, we will have to maybe note a couple of the last question on aluminum and this one. What we will do is post the answers on the portal.
Okay.
Not all
Dr. Rakib,
questions.
if you cannot speak, I have assigned the question to you. You can answer it via text also. So that kind of flexibility is there with you. Anyway, I have noted down the questions, so we can answer them afterwards.
Okay.
Let me go through other questions. Someone is asking for which IBC responds to BNBC 2020. I think that has been answered already, right?
No, has not been answered. Which IBC corresponds to? Yeah, the best answer is 2009 IBC. Okay, did you get that? Yeah, I did look into it. It's so it is ACI 31808, ASC 705, and 2009 IBC.
Okay, so there is one question. How to measure the structure lifetime Is there a guideline in BNBC 2020 or any code?
How to measure the lifetime of a structure?
Yeah. Yes.
I don't believe so.
Yeah.
I mean, it's not only not in the code. I do not know where one would find an answer. But these days, best
Yeah, you can measure a performance of a structure, but that is a different thing.
different thing. Yeah.
Yeah, it's not a structure lifetime.
I don't even know that it's a measurable thing. I mean, when
Yeah.
does a structure die is the question, you know. So that has to be defined. So I no, there is no code provision, I'm sure.
Is one related to seismic? Should I read it out or?
Sure.
Is it possible to make an approximate relation between earthquake magnitude and base shear of that earthquake?
No, absolute no. Earthquake magnitude is energy released at source. And what a structure feels is the ground motion at a site. I will go into all of that in I think one of the probably the first or the second lecture, but the answer to your question is a definite unambiguous no.
Yeah. So there is one question for construction practice. In construction practice chapter, I expect your valuable comments on the basic difference between retrofitting and strengthening. We often mix those, I think.
Read the thing again.
So in construction practice chapter,
Mhm.
I expect your valuable comments on the basic difference between retrofitting and strengthening.
Mhm.
We often mix those. That's what he said.
Yeah, I hesitate to. I think the words should be taken at basically at their dictionary meaning. Strengthening is exactly what it says. You increase, you enhance the strength of an existing structure. Retrofitting, by definition, means you bring it back to the shape it was in to start with. Retrofit. So it was a structure providing service, and then something happened. It could be age, it could be an earthquake, it could be termites. It's not what it used to be. You bring it back to what it used to be, or something very close to that. That's retrofitting. You do not strengthen it. You do not try to make it any better than it was. Okay. So strengthening is exactly what it says. You make a structure stronger for whatever reasons, and the reasons better be good and compelling. Retrofitting, on the other hand, is something like restoring it. You bring it back to what it was, to the extent practicable.
Okay. So the next question is, will we get the video of this training? Yes, we are recording these webinars, and uh, mm, like in future, we will actually upload all the videos so that you can go through the videos whenever you want. So that is in our plan. And okay, is it total floor area or each floor area considered in case of categorization of buildings to be supervised or designed in BNBC 2020? So he's referring to slide number 52, Dr. Ghosh.
Slide number 52. This slide set?
Yeah, yeah.
Can you take me back? I don't know.
Just press
Oh,
escape.
let me, no, it's not working somehow. Oh, okay. How do I know when it's slide 52?
Uh,
There is no slide number.
and can't you press escape once?
Okay. Well, this is 40 or 56. Okay. So I've gone too far. So what's the question?
Is it total floor area or each floor area considered in case of categorization of buildings be supervised or designed in BNBC 2020?
No, this one put in the category of we will post an answer because I don't want to answer without looking at the provisions. Dr. Rakib might know, but I don't. I don't deal with the fire related provisions. So
Okay, okay. So no, I think the next question is also like something Dr. Rakib will answer easily.
yeah.
It is in BNBC 2020, how much live load are considered for mosque? I did not get in the live load cases.
Let me see if I can easily find. Yeah, I probably can find it, but it will be easier to post it.
Okay. Okay. Is there any calibrated design life for buildings in BNBC like in bridge codes?
Say that one more time.
Is there any calibrated design life for buildings in BNBC like in bridge codes? That is ASTO BDM.
No, I don't think so.
Yeah. Okay. What is the basic rule of reduction of live load and why?
Okay. Why part is very clear. Uh, Reduction of live load. The idea is if you have a large area, it is extremely unlikely that the entire area will be loaded with the full design live loads. The larger the area, the more unlikely it is. So the larger the area, the larger the reduction we take on the design live loads. Yeah. So, so the reason for live load reduction is exactly what I said. If you have a large area, it is extremely unlikely all of the area will be experiencing the full design live load. So the reduction depends on the area on which the live load acts in one way or the other. That's what it depends on. And the way we do it has changed in ASCE 7. It used to be based on tributary area. Now it is dependent on influence area, but that goes into details that may be unnecessary at this time. So the basic idea is what is important, and live load reduction is about the fact that on a large area, the entire area will not be fully loaded with the design live loads.
Rest of the questions, I think more or less you answered already. And there are a lot of questions that are coming. I don't know how many are you going to take right now. So yeah, there are a lot of questions coming.
if
I'm just
there
going through.
if
Yeah.
there if they're meaningful questions, I don't know. I mean, this was a good question on live loads.
Right. I'm just trying to see like if, because most of the questions you already answered in some way right now.
Okay.
So
Take your time. If you find something, we have, I think we scheduled it up to 11.
right. A lot of the questions are on determining service life or
Mm,
life of a structure. So that you already.
mm.
So will you share the presentations with participants? The presentation is already shared. That will be in the webinar material tab. When you go to the Essence training page, you will have an option called webinar material. So just click on that. You will see the presentation there.
Okay, you are not finding new
Yeah,
ones.
yeah. Most of the questions if I read, you will say that it has been answered in somewhere. So
Okay.
I'm not going over those questions. But like so there's one like, can anyone use BNBC 2006 instead of 2020 still now? So that is,
No, no,
yeah.
no. I think on one of my slides I said that once a new code goes into effect, all the submissions have to be according to that new code. And it has been my understanding that when BNBC was gazetted, February, whatever the date it was, it went into effect. So now the submissions have to be by 2020 BNBC, not the old one.
So one of them is why seismic zone increased from 3 to 5 in BNBC 2020.
Yeah, that I don't know what the answer would be. Bangladesh Geological Survey data accumulated by Bangladesh Geological Survey made it more logical to have an additional zone. The previous division was too crude. Now we had more measurements from, as I said, Bangladesh Geological Survey and other sources, which made it logical to make a finer, less crude division than before. It is pretty much as simple as that. It was a judgment call by those involved. There is nothing hard and fast about it, but this is a refinement. This is a better way to approach the seismic design problem. There is no reason to be any. There is no reason to continue to be crude as before.
Right. So I think I will just read this question out because there are a lot of questions related to it, and you have already answered, I know, but
Mm, mm.
because they're still asking, so maybe a clearer answer will help them. So for buildings built with previous version of BNBC, how much alteration or addition to okay, uh, let me rephrase the question. For buildings built with previous version of BNBC, if one column of the entire building needs retrofitting, should we impose BNBC 2020 for this one retrofitting or use the code, initial code? So that's
No, this I have actually answered.
right.
So the entire building does not have to comply with the new code unless whatever alteration you are making goes beyond a certain threshold. Okay, one column in a multi-story building will not force the whole building to comply. The column that you are uh, altering in whatever way, that column has to comply with the new code, that column itself, not the rest of the building.
I think that answers all the questions related to it. A lot of questions related to them.
Mhm,
So
mhm,
I just wanted to.
mhm. Yeah, so there are always triggers. Alteration has to go beyond a certain threshold for the entire altered building to have to comply with the new code.
Okay, if some beams of a RCC structure is over reinforced, can we say the structure is one, not compliant with BNBC 2020 or ACI 31808, and two, not structurally safe?
Read the beginning, read it one more time.
If some beams of a RCC
Some
structure,
beams, some
yeah,
beams. Okay, yeah.
some beams, yeah,
Mhm,
of a RCC structure
mhm,
is over reinforced,
mhm.
can we say the entire structure is not compliant with BNBC 2020 or ACI 31808, and two, not structurally safe?
The answer to the first question is yes. The over-reinforced beams are not allowed to be built by ACI 318 or BNBC 2020. So if some beams are over-reinforced, those beams are out of compliance, and it cannot be that the beams of a frame are out of compliance and the frame is in compliance. So you have to say the structure itself is out of compliance. Is it unsafe? In my judgment, it is unsafe. As I said, an over-reinforced member fails explosively all of a sudden without warning, and that is not a good situation to have. So if evaluation actually indicates that certain beams in a structure are over reinforced, it will be very, very desirable to bring those beams into compliance. And when I say compliance, compliance should be the new code. Now, if 100 beams in a building are out of compliance, then the trigger will go off and you may have to bring the whole building into compliance with the new code. I wouldn't be able to tell you without knowing the extent of it. But this is an unsafe situation, yes, should be taken seriously. And yes, your building is out of compliance.
Okay. So nowadays, 60 grade rebars are not available. Most of the rebars that are found is 72 grade,
Mm.
but SMF structure, especially seismic zone 3 and 4,
Mm.
it is restricted to 60 grade. So what should I do in such situation?
What structures are restricted to 60?
The special moment frame
Oh,
structure
oh.
for seismic zone 3 and 4, it is restricted to 60 grade.
That is a good question. I will get into that in probably the first concrete course on materials? Yeah, this is a good question. Let me not try to answer it now.
Yeah. I'm just going through the other questions.
But this keep this question. I do want to deal with it. Maybe separately email it to me.
Okay. Okay. If we reduce live load for foundation calculation, do we need to consider the reduced live load for superstructure?
I don't understand the
I
question.
didn't understand the question here.
Foundation loads come from the superstructure. So how?
It needs more explanation.
We reduce the live loads floor by floor, starting at the top. And so it's the floor live load, beam live load, then column live load, shear wall live load, and whatever is at the base of the column or the shear wall goes to the foundation. This is how calculations are done. So you are asking it backwards. I don't quite understand.
So rest of the question, I think you answered in one way or the other.
Okay.
But I'm still getting questions. I don't know. Maybe they missed it or something. So let's go over the questions afterwards and try to come up with answers or something like that and put an FAQ page on these. What do you suggest?
It will be considering that the number of courses we are doing, it will be not possible to go back and answer questions. That's what happened the last time. We
Right.
just do not have the time and the resources to do that. So the best we can do is kind of skim through as you are doing. And some have been answered. If we find others that require an answer, then then maybe we should try to post an answer.
Right.
So I would suggest maybe print them out. Maybe it has to be probably this afternoon that somebody needs to go through them and make a selection. And those few we will try to answer.
Right. Okay. So I think most of the questions.
I think we should conclude. It has been a
Right.
pretty long session. Yeah. Again, I'm glad that we got started, and we will go from there, hopefully, to a successful end. Thanks a lot for those who attended. What was the attendance?
It was around 810. So
nice. That is a very encouraging thing. Yeah. Okay.
yeah, I will open up the quiz now, so you guys can go and just reply, just put your answers there, and we'll see you in the next webinar.
Yeah. Thank you.
Thank you so much.